A singular Big Bang. Most scientists believe the universe began from a singularity, an impossible-to-imagine point, so small that it had no size at all. Then that point, which they think contained everything that there is in the universe, matter, energy, and even time and space, exploded with an enormous rush. Scientists don't know what caused this point to explode in a Big Bang about 15 billion years ago, and they don't know what, if anything, existed before the bang occurred, or even if there was a before it happened. So-called black holes are believed to be similar to this singularity, except that they contain far less of the universe. Black holes are believed to be collapsed stars of such density and gravitational strength that once caught, nothing, not even light, can escape their pull. Scientists believe that as the Big Bang exploded outward in a blaze of energy, the universe was blown up like a child blows up a balloon. Heavy elements created. Scientists believe that as the universe expanded following the Big Bang, it cooled rapidly, and some of its energy condensed into tiny particles. Then an unexplained phenomenon called electromagnetic force began pulling these tiny particles together into hydrogen atoms. Gravity, another mysterious force, caused more atoms to gather. The larger these clouds of atoms, the stronger the gravitational force became, until the pressure squeezed the atoms so hard that it sparked a nuclear reaction, and the clouds became huge balls of fire. Stars blinked on all over the universe. These stars burned at tremendously high temperatures as their hydrogen atoms joined to form helium atoms in a process called fusion. Small stars can burn like this for billions of years until they run out of hydrogen. Then they cool down and collapse, becoming white dwarfs. But the largest stars burn up much more quickly, then collapse, fusing their atoms together into heavier elements. Finally, they explode into supernovas, scattering new atoms of copper, gold, uranium, and many other elements into the surrounding galaxy. The Earth and all its plants and animals were formed from these heavier elements. Universe at a glance. In this artist's illustration, you can follow scientists' current understanding of the steps that occurred in the formation of the universe. At the far left is the Big Bang, the explosion that marked the beginning of the universe. Why the bang occurred and where the material came from that exploded is still unexplained by science, but what follows is more clear. To the right of the Big Bang, you can see the great stretches of hydrogen that made up the early universe, and following it, the condensation of hydrogen into large clouds, and then into an early star, one of billions. In the next image, you can see our solar system begin forming, and then, finally, Earth. How the solar system started. Though the details are not fully understood, it appears our solar system started about 4.6 billion years ago as a whirling disk of hot hydrogen gas mixed with heavier atoms from ancient supernova explosions. Gravity pulled the hydrogen together toward the center of the disk. The hydrogen became more and more compressed until a nuclear fusion reaction began, generating energy. The sun was born. The remaining 0.1% of solar material condensed into smaller bodies that eventually became the planets. Leftovers became moons, comets, and asteroids. From dust cloud to our house. Way out in the boondocks of the Milky Way galaxy, about 4.6 billion years ago, a cloud of gas and dust began to come together into a rotating disk, attracted by its own gravity. As this disk formed, gravity squeezed a large lump of gas at the center so hard that the hydrogen atoms began to fuse together, creating a nuclear reaction and igniting the fires of our sun. Orbiting the sun, other clumps formed, eventually becoming planets, one of them the Earth. Those close to the sun, Mercury, Venus, Earth, and Mars, became small and rocky planets. Those farther away mostly became large gas-covered planets. Jupiter, Saturn, Uranus, and Neptune. When Earth was first formed, you couldn't have lived on it. It was extremely hot, and there was no oxygen to breathe. It took a long time for our planet to be ready for plants, animals, and people. Though Earth was once very hot on its surface, today it has cooled. But the natural radioactivity of rocks keeps the inside of our planet hot. Large sections of the Earth's surface drift around slowly. Life. How did it happen? Here you can see an outline of the history of the universe. In the sky are galaxies and the comets, planets, and moons that formed in the solar system, plus, of course, the sun, on which all life depends. In the ocean at the far left are the molecules that make up life. As you look to the right, you can see the bacteria that were the first cells of life, followed by more complex sea life, and finally, land life. This is the story science tells us. But how did it happen? Many scientists believe that by chance, molecules combined into simple life forms, and experiments have shown that with the right atmosphere, lightning and solar radiation could create simple amino acids that are the building blocks of life. Then these amino acids could combine into simple life forms, and these in turn could change into increasingly complex life forms by the process of evolution outlined by naturalist Charles Darwin. Some scientists, however, don't believe this. They think that early life may have come from outer space. Why? Because, in the words of scientists Francis Graham Smith and Bernard Lovell, the possibility of molecules randomly combining into life within no more than 1 billion years is vanishingly small. Therefore, some scientists, such as geneticist Francis Crick, have concluded that early life must have come from outer space. Earth, the once poisonous planet. For nearly 1.5 billion years after the formation of the Earth, the planet was a seething, poisonous place, filled with volcanoes and covered by dark clouds of water vapor and poisonous gas. There was no life anywhere on the planet, and the air, water, and land as we know them today did not exist. It took hundreds of millions of years just for the Earth's molten surface to finally cool and harden. As it did, poisonous gases and water vapor were expelled from the Earth's core, creating the first primitive atmosphere. No living thing could have breathed in that atmosphere, since there was no oxygen, and most of the gases in it were deadly. All around the planet there were erupting volcanoes and lakes of lava. Over time, the Earth's surface cooled enough so the water vapor in the atmosphere began to condense and turn into rain. Then, for millions of years, it rained nearly continuously, filling up the depressions in the Earth's surfaces with what are now our seas and oceans. Eventually, the rain stopped, and the clouds covering the Earth thinned. For the first time in many millions of years, the sun shone through to the Earth's surface. At around the same time, much of the poisonous gas in the atmosphere escaped into space, setting the stage for the development of the first life forms. A molecule is born. All life forms are made mostly of a few common atoms, such as hydrogen, oxygen, nitrogen, and carbon. These atoms stick together in groups, called molecules. Atoms are like the letters of the alphabet. Molecules are like words, formed from those letters. A few letters can make an endless variety of words. Many scientists think that after the Earth formed, the atmosphere consisted mainly of hydrogen, ammonia, and methane. These, dissolved in the ocean, were the basic ingredients of life. The chemicals mixed in the water, forming a soup of more complicated molecules. Sunlight provided the energy to cook the soup. Lightning accelerated the process, helping more complex chains of carbon atoms to form. By recreating what they believe the surface of the early Earth must have been like, scientists have created some of the organic compounds from which life is built, but they are still far from creating life. For life to exist, carbon is very special. Most atoms can only stick to themselves in small clusters, but carbon is unusual in that its atoms can stick to each other in endless chains like sticky marbles. Perhaps when conditions were perfect, some complicated molecules formed in the early seas, then broke into two identical halves. Then when the right molecules, food, stuck on them, they might have formed identical copies of themselves. This would have been the first self-reproducing molecule, meaning that it made identical copies of itself, like a tiny photocopy machine. Each of these copies could then split in two and form more and more copies, multiplying throughout the oceans like rabbits. Perhaps this was how life began. The mystery of life. The first thing to remember about simple life forms is that there is nothing simple about them. The most basic cell has been compared to a factory carrying out as many functions as every type of factory on Earth put together. Therefore, it is still something of a mystery how living things were first formed. But many scientists believe that in Earth's early ages, rain carried chemicals from the air and ground into the oceans, making a salty soup out of which life evolved. Though the molecules that make up living things are much more complicated than those found in the primitive oceans, experiments have shown that when acted upon by certain sources of energy, chemicals found on the young Earth could have produced the amino acids and nucleotide bases which are to life as bricks, for example, are to buildings. Other theories suggest that these building blocks could have hooked together into more complicated proteins and nucleic acids to form protocells, precursors to true living cells. Some scientists theorize that after eons of reacting with each other and with other chemicals, protocells somehow developed skins that could absorb chemicals and grow larger without bursting. Gradually, over many generations, surviving protocells became more complex, until some of them were able to grow and then split into two identical copies of the original cell, at which point they would be alive. But other scientists, such as Nobel Prize-winning biochemist Francis Crick, consider this chain of events so vastly improbable that they speculate early life forms may have drifted in from outer space. Scientists are still searching for definite answers to the complex mystery of life. Earth comes alive. Close to 2.5 billion years ago, the Earth's surface and atmosphere were stable enough to support the first forms of primitive life. In the giant seas that covered the planet, single-cell organisms began to make their appearance. Most of them were very simple single-cell bacteria that fed on chemicals in the ocean's waters. Over time, a simple organism known as blue-green algae appeared and spread across the seas. Blue-green algae, still alive today, were important to the future of the planet because they used sunlight and water to make food, and in the process created oxygen. As the blue-green algae thrived in the Earth's seas, they began to fill the atmosphere with oxygen. Soon the algae became so numerous that they formed huge reefs called stromatolites. Trilobites were small shellfish that lived in the shallow oceans of the Cambrian world. They crawled along the bottom of the ocean, dug into the mud, and probably ate all kinds of things. They only lived in the ocean and never went onto the ground, or even into freshwater streams. These little creatures, which ranged from about 3/4 of an inch to 3 inches long, were divided into 3 parts: the head, thorax, middle part, and tail. They had gills, legs, and eyes. Though they were the first animal with eyes, their eyes were not simple. Some trilobite eyes had many lenses, sometimes as many as 12,000 to 15,000. Trilobites came in an amazing variety of forms, and like lobsters and shrimp today, they had an external skeleton which they shed when they grew too big. They appeared suddenly about 590 million years ago. Scientists are not sure where they came from, though some think they evolved from worms. They lived for more than 300 million years, then disappeared at the end of the Permian period. The explosion of life. About 570 million years ago, nothing much seemed to be happening on the Earth's surface. The upper atmosphere was finally strong enough to keep oxygen created by algae from escaping into space. Volcanoes continued to erupt, but no longer with the same intensity. Beneath the seas, however, a tremendous abundance of living creatures suddenly began to flourish. During this time, known as the Cambrian period, the world's seas filled with corals, sponges, and anemones. Ancient shellfish, such as oysters, mussels, and bivalves, also began to cover the sea floor, while worms, jellyfish, and primitive squids floated along the water's currents, scooping up algae and other organisms for food. Earth on the move. Ever since the Earth's formation 4.6 billion years ago, the surface of the planet has not stopped moving. That's hard to believe when you consider how enormous the Earth's continents and oceans are. Yet beneath the surface of the planet lie massive plates of rock which move ever so slowly over the Earth's molten core. As these plates move, they carry the continents with them, sometimes in very different directions. This is what scientists call continental drift. Over hundreds of millions of years, the slow movement of these plates has caused the Earth's continents gradually to shift their positions all over the planet. Of course, this movement is so slow that it is almost impossible to detect, except with the most precise scientific instruments. However, it is possible to see the effects of these shifting plates all around us. For instance, when plates collide into one another or grind past each other, they push up layers of rock and earth on the planet's surface, creating mountains. Other times, the friction of two plates rubbing against one another can cause an earthquake. The large earthquakes that frequently strike California are the result of two enormous plates grinding against each other. Eventually, it is said, Southern California will slide so far to the northwest that it will become an island or peninsula near the San Francisco Bay Area. Plants invade the land. About 400 million years ago, the surface of the Earth went through dramatic changes. The collision of the planet's shifting continents created large ranges of mountains, which helped to raise the level of the land. As the water fell in many places, the first plants began to invade the land. These were close relatives to seaweed and other ocean-going plant life. Without water surrounding them, however, these plants developed roots to absorb moisture from the ground, stems for support, and a tough texture for their leaves in order to keep them from drying out. The most primitive land plants were very small and mossy and stayed close to the shores of seas or lakes. Sometime in the middle of the Devonian period, about 345 to 400 million years ago, the first ferns appeared, initially without leaves and seeds. Gradually, these ferns developed leaves and very strong stems, with some growing as tall as trees. At the water's edge, something more amazing was taking place. Crabs, spiders, mites, and other non-flying insects began to emerge. They thrived in the swampy jungles that were spreading across the Earth's landscape. Before reptiles could spend all their time on dry land, they had to develop a new way to give birth to their young. No matter how much time amphibians spent living on dry land, they always had to return to the water in order to lay their eggs. That's because baby amphibians, known as larvae, were too small and frail to survive on land without being crushed or drying out. So about 400 million years ago, certain amphibians began to lay a new kind of egg. It was called the amniotic egg. An amniotic egg is a specialized egg that is very similar to the eggs that birds and lizards lay today. The first amniotic egg was covered by a leathery shell, not a hard shell like a chicken egg, and contained everything needed for a young, undeveloped animal, called an embryo, to grow into a fully functioning baby that would eventually crack through the shell. Inside, the amniotic egg was divided into 4 major cavities that performed special functions to help the embryo develop. The main cavity held the embryo, which was surrounded by a fluid called the amnion that helped keep the embryo moist and cushion it from the vibrations of the outside world. Another cavity, called the yolk, contained a food supply for the embryo. The waste products from the growing embryo went into another cavity called the allantoic cavity. Finally, oxygen entered through tiny holes in the shell into an area known as the chorion. With sturdy, self-sufficient eggs like these, reptiles were free to move as far as they liked on land. inhabiting new terrain like grassy lands and dry, hot deserts. The world's a jungle. In the Carboniferous period of 360 to 286 million years ago, large swampy jungles like these spread across much of the Earth. The planet's average temperature was much higher than it is today, and the air was humid, making conditions perfect for plants to thrive. Plants such as the giant club moss and the horsetail fern grew increasingly large. They developed thicker trunks and reached heights of 70 to 80 feet. Also, the first trees, known as gymnosperms, began to appear. Gymnosperms are trees like the pine and the ginkgo, which have protected seeds. At the same time, flying insects like giant dragonflies with 2-foot wingspans darted between the vines and branches of the jungles. On the ground, a more interesting development was taking place. Scientists believe lobe-finned fish, with their muscular fins and primitive lungs, were becoming the first amphibians, animals that could spend time both in and out of the water. You can see in this movie that Dimetrodon had sharp teeth. Judging from their shape and from the fact that Dimetrodon lived near the sea, scientists think he probably used them to catch fish. Dimetrodon, sailor or solar. How do you think Dimetrodon, a reptile but not a dinosaur, used this strange sail on its back? Believe it or not, for a while some scientists thought it was actually for sailing, allowing Dimetrodon to sail across the water in search of food. Dimetrodon, which literally means 2 long teeth, had sharp teeth that look as if they would be good for eating fish, and Dimetrodon fossils have been found near ancient lake sites. So it seems reasonable to think that this creature ate fish, though it is also possible it ate other animals as well. However, scientists no longer believe that the sail on its back had anything to do with sailing. Instead, they think that Dimetrodon could face the sail toward the sun to warm itself quickly, or turn the edge of the sail toward the sun to cool itself. Also, the sail may have been brightly colored and used to frighten rivals or predators, as well as to attract mates. Estimenosuchus, mammal reptile. This mammal-like reptile, called Estimenosuchus, lived in the Permian period, just before the Triassic, when the dinosaurs appeared. Estimenosuchus means strong garment reptile. It had large, sharp front teeth, but tiny side teeth, suggesting it ate plants. Its skull, about 36 inches long, was heavy and had bony lumps on its forehead and snout, perhaps for fighting other male Estimenosuchuses. Were dinosaurs warm-blooded? Most scientists have thought that dinosaurs were cold-blooded animals. It seemed reasonable. Modern reptiles are cold-blooded, so if dinosaurs evolved from ancient reptiles, they were probably cold-blooded too. But one scientist, Dr. Bob Baker, has said dinosaurs were warm-blooded. Here are some of his arguments. Almost all animals that walk upright today are warm-blooded, and dinosaurs walked upright. The hearts of warm-blooded animals can pump much more effectively than the hearts of cold-blooded animals. Therefore, the giant Brachiosaurus must have had the type of heart associated with warm-blooded animals in order to pump blood all the way up to its head. Dinosaurs such as Deinonychus led a very active life, which is much more compatible with a warm-blooded animal. Some dinosaurs lived in northern latitudes, where it would be impossible for cold-blooded dinosaurs to keep warm, though critics point out that the northern latitudes were warmer in the days of the dinosaurs than today. Critics of this theory, however, say that cold-blooded animals tend to have smaller brains than warm-blooded ones, and for the most part, dinosaurs have small brains, though there are some examples of dinosaurs with larger brains. The warm-blooded dinosaur theory is still much in dispute. Euparkeria. The ancestor? Euparkeria, a small, lightly built reptile, is of interest to scientists because it may be the ancestor to both the dinosaurs and crocodiles. This is not certain, though, because the ankles, which would give the best evidence, are not well preserved. This little meat-eater, just 2 feet long, probably walked on all 4 feet most of the time, then got up on its 2 powerful back feet to run when it needed to escape danger. It had a long tail, about half as long as its body, and bony plates down the middle of its back and tail. Euparkeria means good parkers, after British scientist W.K. Parker. Triassic period. The dinosaurs begin. The Triassic period was the beginning of the age of the dinosaurs. During that time, all the land on Earth was in one gigantic mass, with a huge bay called the Sea of Tethys. Most of the interior of the land, called Pangaea for all Earth, was desert since it was so far away from the rain clouds that gathered above the sea. The climate was warm, and from the ground grew such plants as tree ferns, conifers, and cycads, a palm-like plant. There were animals we know today, such as frogs and crocodiles and turtles. But there were also mammal-like reptiles, little mammals and four-legged reptiles known as thecodonts, which scientists think were the ancestors of the dinosaurs. Then, about 225 million years ago, toward the end of the Triassic period, the first real dinosaurs appeared. For the most part, these were smaller dinosaurs, such as Coelophysis, about 10 feet long, and Ankylosaurus, about 7 feet long. But it would not be until the Jurassic period that the dinosaurs really came into their own. Plateosaurus, first large reptile. Plateosaurus, or flat reptile, was one of the first large plant-eating dinosaurs, known as prosauropods. These were the ancestors of the much larger sauropods, which includes Brachiosaurus and Apatosaurus. Plateosaurus lived during the late Triassic and early Jurassic periods, and ranged all over what is now northern Europe. At a major fossil site in Germany, dozens of Plateosaurus skeletons have been uncovered at the same location, leading some scientists to believe that this dinosaur traveled in large herds, as it browsed among trees and bushes, which were its food. Plateosaurus measured up to 23 feet long, with a tail that made up almost half of its length. Plateosaurus had a rather small head compared to the rest of its body. Its many leaf-shaped teeth had large, coarse serrations, very similar to modern plant-eating lizards. Plateosaurus probably spent most of its time walking around on all fours, though occasionally it reared up on its strong back legs to nibble at the tops of trees. Dinosaurs roamed the Earth. Looking down on Earth from space 200 million years ago, you would have seen a very different world. Instead of the familiar continents, you would have seen one supercontinent called Pangaea, and one gigantic ocean, and on the Earth would be large ferns and conifer trees, many that would be strange to us today. Most impressive, though, would be the dinosaurs. While some of these reptiles, whose name means terrible lizard, were as small as a chicken, others were taller than a 3-story building. These great creatures appeared on Earth about 225 million years ago, and ruled until about 65 million years ago. The first part of their reign was during the Triassic period. During that time, all the Earth's land was in one continent, so the dinosaurs could spread freely across the Earth. Also, the weather was warm, and swamps covered much of the land. During the next period, the Jurassic, the weather remained warm, and plants and animals increased rapidly. But the continents had begun to drift apart. The Cretaceous period marked the end of the dinosaurs. The continents drifted further apart, and the Earth's climate became more varied. Hips make the dinosaur. One of the main ways of classifying dinosaurs is by their hip type, either Saurischean, meaning reptile-hipped, or Ornithischian, meaning bird-hipped. All dinosaurs can be divided into one of these two groups. Dinosaur hips were made up of 3 bones that could be found on each side of the pelvis: the ilium, the ischium, and the pubis. In reptile hip dinosaurs, the ischium pointed backwards and the pubis pointed forwards. With these dinosaurs, the joints and connections between the hip and leg bones were very simple, which made it possible for the dinosaur to carry its legs directly beneath its body. In this fashion, the legs acted like the pillars of a building, capable of holding up a substantial amount of weight. Among the reptile hip dinosaurs, there were meat eaters, such as Tyrannosaurus, and plant eaters, such as Diplodocus. Bird hip dinosaurs, on the other hand, were all plant eaters. Their hips were different from reptile hip dinosaurs because their pubis pointed backwards along with the ischium. Bird hip dinosaurs included some of the more distinctive-looking dinosaurs, such as the heavily armored Ankylosaurus, Stegosaurus, and the crested Corythosaurus. Coelophysis, the cannibal. This small, compact dinosaur was built for speed and agility. While Coelophysis stood only about 7 feet tall, its powerful rear legs and long, slender body made it a fast and deadly predator. It had a long, narrow head and a mouth filled with numerous razor-edged teeth. Unlike other dinosaurs, the leg bones of Coelophysis were nearly hollow, which helped reduce its total body weight and increase its speed. In 1947, dozens of Coelophysis skeletons were found in a mass grave in New Mexico, which has led many scientists to believe that these dinosaurs hunted in large packs. Strangely, at the same location, some adult Coelophysises contained the skeletons of their young. At first, this was thought to be proof that they may have given birth to live young, rather than laying eggs like other dinosaurs. But now it is believed that Coelophysis was probably a cannibal that occasionally ate its own offspring. Coelurosaurs, little meat eaters. The coelurosaurs were little two-legged meat-eating dinosaurs. Their name means hollow-tailed reptile. This classification, which is one of convenience, since coelurosaurs were not all related, includes the little Compsognathus, Ornitholestes, and Coelophysis. Ankylosaurus, typical prosauropod. Though Ankylosaurus was found in 1818, it was not until 1885 that it was recognized as a dinosaur. Ankylosaurus, meaning near reptile since its body was found near the surface of the ground, had a slender nose, somewhat triangular head with diamond-shaped teeth that looked like they would have been good for eating leaves. It also had a long neck, body, and tail. Ankylosaurus's long, narrow feet had large, curved thumb claws that it could probably use for digging up plants. The arms of this early Jurassic dinosaur were about a third as long as its back legs, so it probably spent most of its time walking on all fours, but may have stood on its back legs to reach food. Lesothosaurus. Feeling sleepy? Little Lesothosaurus was built for the hot, dry plains of southern Africa. Its skeleton was lightweight, with hollow limb bones, long back legs and a slender tail, short arms and a flexible neck. 2 Lesothosaur skeletons were found curled up together, as if they were estivating, like hibernating but during the summer so as to escape the heat. And around them were a set of worn-down teeth, though each dinosaur had a full set of teeth. Maybe while they were sleeping, they grew new teeth. Jurassic. Dinosaurs rule. The supercontinent Pangaea began to break apart during the Jurassic period. It split into Laurasia in the north, including what is now North America, Europe, and Asia, and Gondwana in the south, South America, Africa, Antarctica, Australia, and India, and creating the Atlantic Ocean in between. During this time, the great interior deserts became closer to the ocean, and therefore moister. Plants such as the short palm-like cicadioids, tree-like cycads, ferns, and tree ferns began to flourish in a wide variety of places. Shallow seas covered much of Europe and North America, and became the playground not only for fish, but also for large marine reptiles, such as the plesiosaurs and ichthyosaurs. Above the sea and land, flying reptiles and birds swooped and dived. New varieties of plant and meat-eating dinosaurs appeared, and some grew huge. The famous sauropods, such as Diplodocus, roamed the earth. But there were also two-footed dinosaurs, both plant and meat-eaters. Mammals at this time were mostly small burrowing or climbing animals, who apparently tried to stay out of the way of the big meat-eaters. But the last and longest period of the dinosaurs was yet to come. It was the Cretaceous period. Scutellosaurus, early bird hips. One of the earliest ornithischian or bird-hip dinosaurs was the armored Scutellosaurus. It was an unusual creature because most armored dinosaurs had 4 legs, but Scutellosaurus walked on 2 legs. Scutellosaurus was about 4 feet long. It had a slim head and strong jaws for eating plants. Its very long tail may have been a good whip to use against predators. Scutellosaurus means shield reptile and takes its name from the several hundred little bony plates that cover its neck, back, ribs, and tail. Some scientists think Scutellosaurus may be the ancestor of other armored dinos like Stegosaurus and Ankylosaurus. Plesiosaurus, reptile of the sea. Plesiosaurus was the earliest member of the ocean-going group of reptiles called plesiosaurs. These 7-foot-long marine reptiles cruised the shallow seas around England and Germany in search of their prey, smaller fish. Instead of limbs like other reptiles, Plesiosaurus developed long, narrow, penguin-like flippers and short tails. Plesiosaurus, or ribbon reptile, used its paddle-shaped flippers much like a sea turtle does. Instead of rowing backwards and forwards, Plesiosaurus flapped its paddles up and down, so that it probably looked like it was flying through the water when it swam. Plesiosaurus also laid its eggs just like a sea turtle does, in nests that were dug out in the sand. Because of their long necks and lack of any protective armor, they would have been easy prey for enemies as they waddled up the beach to lay their eggs. Plesiosaurus was an expert fish catcher. Held high above the water with its long neck, Plesiosaurus's head could spot fish beneath it and then snap them up with its razor-sharp teeth. Dilophosaurus, the first terror. One of the first terrible meat-eaters was Dilophosaurus, first found in Arizona. Generally, Dilophosaurus resembled other meat-eaters. It was fast and agile, ran on 2 feet, had a long tail and sharp teeth. But there were some odd aspects to it. On the top of its head, from the front of its snout to a point between its eyes, ran 2 bony crests. The crests were quite thin, so it is unlikely they were used in combat. Scientists don't really know what they were for, but they may have been used as a sexual signal to females, or to make their heads look bigger and frighten other animals. Also, Dilophosaurus's teeth were long and slender, and its jaws were not as strong as other big meat-eaters. This has led scientists to think that they may have slashed repeatedly at their prey, rather than killing them with a few bites. Or perhaps they were scavengers. Dinosaurs' bumpy skin. Dinosaurs were covered with scales, not like the scales of a fish or the feathers of a bird, which overlap, but more like the skin of a crocodile. Dinosaur scales were thick, round, or multi-sided bumps, arranged edge to edge in a pebbled pattern. The scales were bigger where the skin did not have to bend, and smaller where it needed to be flexible. Some dinosaurs, such as the ankylosaurs, had bony plates attached to their skin for additional protection. Some scientists think a few types of dinosaurs had feathers. The reason they believe this is that if dinosaurs evolved into birds, they must have had feathers before they began flying. Nobody has found feathers on dinosaur fossils, but Russian scientist Seryoja Kurzanov found a dinosaur with a ridge along the back edge of its forearm that he thought might have been where feathers were attached. While we know a little about dinosaur skin, we know nothing about its color. All scientists can do is guess from the colors of today's animals. Perhaps some dinosaurs were colored to blend in with their background. Maybe the biggest plant eaters were just one plain color, like the elephant, since they didn't need protection. Perhaps some were bright colors to attract a mate. We don't know, but it is fun to guess. Unanosaurus, strange teeth. Unanosaurus, named for the Chinese province of Yunnan where it was found, is very interesting because its teeth are like those of a different dinosaur. This early Jurassic dinosaur had 4 legs, a long neck, and ate plants. But while Unanosaurus was a prosauropod, its teeth were those of a sauropod, such as Brachiosaurus. Not only were its 60-plus teeth shaped like those of a sauropod, they even wore down like those of a sauropod. As many as 20 of these animals have been found in China. Stegosaurs, roofed reptiles. The stegosaurs, roof reptiles, were the largest plated dinosaurs. They lived from the late Jurassic period to the end of the Cretaceous. Stegosaurs walked on all 4 feet, ate plants, and had 2 rows of plates or spikes along their backs and necks. Some grew to as long as 30 feet. But compared with their bodies, their heads were small, with little teeth and a toothless beak at the front of their mouths. Fossils of stegosaurs have been found around the world, in North America, Europe, Southern Africa, India, and China. Megazostrodon, the first mammal. Contrary to popular belief, mammals appeared on the Earth almost as long ago as dinosaurs. In fact, tiny shrew-like animals such as Megazostrodon were alive throughout the entire age of dinosaurs, scurrying among the legs of the giant Apatosaurus and ducking for cover when the voracious meat-eater Coelophysis came hunting for food. These early mammals were small and furry and looked a lot like modern mice. They were also warm-blooded and suckled their young babies. Despite these many mammal-like characteristics, it is thought they still laid leathery eggs. Mammals like Megazostrodon may have evolved from a special group of reptiles during the late Triassic or early Jurassic period, some 208 million years ago. During that time, these animals developed traits that made them well-suited for a highly active lifestyle. As opposed to having only one kind of teeth, as most reptiles did, early mammals developed four types. Their skeletons changed so that their limbs were more flexible and able to move more quickly. Also, mammals developed a shorter rib cage and larger lungs, which could inhale and exhale more rapidly. Most importantly, though, mammals like Megazostrodon became warm-blooded, which meant they relied on the food they ate for sustaining their body temperature, rather than the outside environment. That enabled mammals to maintain a higher level of activity throughout the day than cold-blooded reptiles could. Megazostrodon's diet probably consisted of small insects and reptiles, and scientists believe that Megazostrodon did most of its hunting and scavenging during the night to avoid being eaten by hungry meat-eating dinosaurs. Dryosaurus, oak reptile. Dryosaurus was a two-legged plant-eating dinosaur with narrow eyes, a stiff tail, and strong legs to run from meat-eaters. To gather food, it had 5-fingered hands on long arms, a beak, grinding teeth, and possibly large cheeks to help it hold its food in place while chewing. Fossils of Dryosaurus, which means oak reptile, have been found in Romania, England, Tanzania, and the United States. Diplodocids, large but light. Some of the biggest and best known of the dinosaurs belong to the Diplodocid family. These dinosaurs had tapering heads, pencil-like teeth, and nostrils on the top rather than on the front of their heads. While the Diplodocids were enormous, they were not nearly as heavy as other large sauropods, such as Brachiosaurus. This was made possible by the way in which the giant bones of Diplodocids were hollowed out and made quite light for their size. The Diplodocids included Diplodocus, Apatosaurus, Supersaurus, and Seismosaurus. They lived mostly in North America, but also in Europe, Asia, and Africa. Stegosaurus, the plate-backed dinosaur. Though not always able to outrun its carnivorous foes, the 21-foot-long, 2-ton Stegosaurus always had a final line of defense: its bony-plated back and spiny tail. If cornered or outmaneuvered by a larger enemy, the Stegosaurus's back plates afforded some protection, while the 4 to 8 spikes on the end of its tail, which grew as long as 4 feet, made it dangerous for any foe to approach too carelessly. Paleontologists still don't agree about the placement of the vertical plates along the Stegosaurus's back, which you can see in this movie. The plates are not attached to bone, but were embedded in the dinosaur's back, which makes it difficult to tell if they were in a single row, double row, or a combination of the two. Many scientists believe the vertical plates may also have served as warming or cooling fins, picking up heat from the sun when the weather was cool to warm the Stegosaurus, or giving off heat when it was too hot. Stegosaurus bones have been found in Colorado and Wyoming. They are believed to have lived primarily in the western part of North America. Patagosaurus, South American sauropod. Patagosaurus was a medium-sized sauropod, about 50 feet long and one of only 2 known sauropod dinosaurs to be found in South America. This creature takes its name from the Patagonia region of Argentina, where it was found. Patagosaurus, minus its skull, was found in rocks about 15 million years older than those in which North American sauropods have been found. Hypsilophodontids. No dentist needed. Hypsilophodontids were members of a very successful dinosaur family. They had large eyes, cheeks to hold food as they chewed, and teeth that sharpened themselves and replaced themselves as they wore out. They had 5 fingers on their hands and 4 toes on their feet. Judging from their long, strong back legs, these 2-legged dinosaurs were very speedy. Hypsilophodontids were herbivores and are believed to have been the ancestors of the iguanodonts and the hadrosaurs. They replaced the fabrasaurs, which became extinct near the end of the Jurassic period. Nests of hypsilophodont eggs have been discovered, with indications that the young stayed by the nest and were cared for by their parents. Hypsilophodonts were herd animals, much like the modern gazelle. Sauropods, giant dinosaurs. The sauropods were giants among dinosaurs. They were large 4-footed plant eaters with long snake-like necks and tails. Some must have weighed more than several elephants. Compared to the size of their bodies, sauropods had small heads, often about the size of a horse's head. Some of the more famous members of this group were Apatosaurus, Brachiosaurus, and Diplodocus. Carnosaurs, the meat-eaters. Carnosaurs, meaning flesh lizards, were the kings of the dinosaur world. They had large, powerful back legs, small front arms, but fearsome claws and teeth. These dinosaurs were probably not unlike the predators we are familiar with today, such as lions and leopards. They probably hunted by themselves, preying on groups of smaller reptiles, such as herds of herbivore. Their favorite prey was most likely weak or slow members of a herd. It is widely believed that some carnosaurs hunted in packs. In this fashion, it was possible for smaller carnosaurs to attack and kill much larger dinosaurs, such as the enormous plant-eating sauropods. The carnosaur classification does not necessarily indicate these animals were closely related, but rather that they shared many similar features. Stegosaurus, the plant eater. Look how big you can grow if you eat your vegetables. Stegosaurus had a small mouth with small teeth, and apparently ate only small plants. But this peaceful dinosaur grew to 21 feet long and weighed up to 2 tons. In addition to having small teeth, Stegosaurus also had a small brain. It may even have had the smallest brain in comparison to its body size of any dinosaur. Stegosaurus's brain was only about the size of a walnut. The word Stegosaurus means roofed reptile. It was named this because scientists originally thought the plates on its back lay flat to form a protective roof. Diplodocus. Light as a feather, Diplodocus was an enormous dinosaur that grew as long as 100 feet. But most of this length was taken up by its incredibly long neck and even longer tail. In fact, Diplodocus's body accounted for only about 13 feet of its entire length, while its tiny head measured a relatively small 2 feet. Diplodocus lived during the late Jurassic period and probably traveled in herds around what is now Colorado, Montana, and Wyoming, feeding on the lush vegetation that thrived at the time. Though Diplodocus was a huge animal, it only weighed 11 tons, about 1/8 the weight of its 75-foot-long cousin, Brachiosaurus. Diplodocus was much lighter than other large plant-eating sauropods because its bones were hollow. Some scientists, but not all, believe that when Diplodocus was hungry, it could stand up on its rear legs and, using its huge tail for balance, stretch to nearly 50 feet above the ground in order to feed on the very tops of trees, about 29 feet higher than today's giraffe can reach. Ornithomimosaurs, The ostrich dinosaurs. Some dinosaurs look quite similar to modern-day ostriches. These ornithomimosaurs were fast dinosaurs with a large brain, large eyes, a narrow toothless beak, and long legs. But unlike the ostrich, they also had short arms. Ornithomimosaurs probably ran exactly like ostriches, taking long, powerful strides on their two hind legs. It is thought that these bird-like dinosaurs ate shrimp and crabs and other shellfish, or maybe insects, small animals, or plants. Oviraptorosaurs were similar in appearance, but had toothless, horn-covered jaws. Their name means egg thief reptile, because it appears they ate other dinosaurs' eggs. Nodosaurids. Bumpy dinosaurs. The nodosaurid family lived throughout the end of the Jurassic period and throughout the Cretaceous period. These dinosaurs were four-legged plant eaters with bony nodes covering their skin and spikes coming out of their sides. They had narrow heads, leaf-shaped teeth, and a strong, hard beak. If a meat eater came along, they probably protected themselves by crouching close to the ground. Camarasaurus. Did it have a trunk? Camarasaurus, or chambered reptile, roamed the moist, lush plains of North America during the late Jurassic period, feeding on the rich vegetation that covered the land. A fairly common long-necked plant eater, Camarasaurus probably traveled in herds that migrated from one feeding place to another. Camarasaurus had a small head which was perched on top of an extra long neck that enabled it to reach even the highest branches of trees in search of food. An adult Camarasaurus could grow up to 59 feet in length and was very similar in build to its close relative, the Brachiosaurus, only much smaller. An odd trait of Camarasaurus was its nostrils, which were placed high up on its head, just in front of the eyes. Scientists once thought that Camarasaurus may have lived mostly underwater, with only its head poking out, using these nostrils to breathe. But that was thought unlikely considering the weight of the water pressure. More recently, some believe that Camarasaurus may have had a long trunk like that of an elephant, which extended down from its nostrils. Others believe that Camarasaurus used its nostrils as a cooling device for the brain. Diplodocus. Teeth like rakes. Imagine eating with just your front teeth. That's what Diplodocus did. The giant Diplodocus, which grew up to 100 feet long, had a set of weak, pencil-like teeth in the front of its jaws only. You can see them here. Notice how dull they are compared to the powerful, sharp teeth of the meat-eating dinosaurs. Because it didn't have back teeth, scientists believe Diplodocus must have used its teeth mostly to rake leaves off of trees, and then swallowed its food unchewed. Perhaps stones that Diplodocus had swallowed earlier would have helped it digest its food. Brachiosaurus, heavier than 12 elephants. It is possible that no land animal, living or dead, was as massive as the giant plant-eating dinosaur Brachiosaurus. Measuring 75 feet in length, Brachiosaurus weighed close to 89 tons, 8 times that of its close relative Diplodocus, and 12 times that of a modern elephant. These giants lived during the late Jurassic period, and their skeletal remains have been found in Africa as well as North America. Brachiosaurus's neck was so long that it made up almost half of its total height. By comparison, its head, which measured 3 feet long, was minuscule. The name Brachiosaurus means arm reptile. It was given to the dinosaur because its front legs were much longer than its hind legs, a very unusual feature for most sauropods. This had advantages, though. When combined with its enormous neck, Brachiosaurus could raise its head close to 45 feet, or as high as a 3-story building. Brachiosaurus was once thought to spend most of its time underwater, using the 2 nasal openings on the top of its head as snorkels. That theory has been rejected because the water pressure on its massive body would have made breathing almost impossible. Allosaurus, giant killer. Allosaurus, or leaping reptile, was one of the most common types of dinosaurs, known as carnivores, or meat eaters. It lived about 150 million years ago, roaming parts of western North America and Africa in search of prey. Though not nearly as large as its close relative Tyrannosaurus, Allosaurus was quite a fearsome killer. An adult Allosaurus could grow up to 39 feet long, 15 feet tall, and weigh between 1 and 2 tons. As you can see in this movie, Allosaurus's skull was quite big in relation to its body, almost 2.5 feet long, and its jaws were lined with about 70 razor-sharp, curved, saw-edged teeth, just like the blade of a steak knife. These teeth pointed backwards, so that huge pieces of meat could be forced down into Allosaurus's hungry mouth. Allosaurus had short but strong front claws, and 4 large claws on each of its back feet, 3 of which helped to carry its weight. These claws also enabled Allosaurus to hold down and tear at its prey. Scientists disagree about the hunting habits of Allosaurus. Some believe that the dinosaur was too large and clumsy to be a very effective hunter, while others argue that Allosaurus was quite agile and hunted down plant-eating dinosaurs in small packs. In fact, in North America, bones of Apatosaurus have been found with teeth marks that match those of Allosaurus. Ichthyosaurus, acrobat of the seas. Ichthyosaurus looked like a fish, swam like a fish, but in fact was a reptile, though not a dinosaur. For nearly 80 million years, Ichthyosaurus cruised the open seas, feeding off of schools of primitive fish, which lived in the shallow waters surrounding the ancient continents. With its dorsal fin, streamlined body, and a strong, flexible tail, Ichthyosaurus resembled a modern dolphin. Like dolphins, Ichthyosaurus was probably quick and capable of impressive acrobatics both in and out of water. Also like a dolphin, Ichthyosaurus couldn't remain underwater forever and had to break the surface from time to time in order to breathe. To locate its prey, Ichthyosaurus had large eyes and heavy ear bones, which transmitted the sounds of the sea. Over the years, scientists have found hundreds of well-preserved fossil Ichthyosauruses in rocks around Europe and North America. Much of that land was once covered by water, so when an Ichthyosaurus died, its body would descend to the sea floor, where it would be covered with sediment and transformed into a fossil. One of the most amazing traits of Ichthyosaurus was that it gave birth to live young rather than lay eggs like other reptiles. Many fossils of Ichthyosaurus have been discovered with young Ichthyosauruses inside the skeleton of an adult. Some fossils even show the body of the baby Ichthyosaurus in the process of emerging from an adult body. Apatosaurus, the giant dinosaur. One of the largest dinosaurs ever was Apatosaurus. A fully grown Apatosaurus could measure up to 70 feet long. As you can see from this movie, Apatosaurus's mouth was designed to eat plants. To grow to such a huge size, it must have eaten tons of vegetation each day. Compsognathus, the bird's ancestor? The smallest known dinosaur, Compsognathus, is believed by many scientists to be an early relative of Archaeopteryx, often considered to be the first bird. Compsognathus, first found in Germany, was about the size of a house cat. It had long back legs, short arms, and a long tail for balancing while running. Apparently, Compsognathus liked to eat lizards, because a lizard skeleton was found in the abdominal cavity of a Compsognathus fossil. One of the most interesting things about this creature is the debate about whether it is a predecessor of Archaeopteryx. Supporting the theory is the fact that the bone structure of Compsognathus is quite similar to that of Archaeopteryx, and the two dinosaurs were about the same size. They also lived at the same time in history, which would have made it difficult for Compsognathus to be an ancestor. It is still possible, though, that Compsognathus lived earlier than Archaeopteryx. On the other side of the argument, Compsognathus had hollow bones, like modern birds, but Archaeopteryx had solid bones. Another objection is that Compsognathus doesn't have a collarbone, and many scientists believe birds' wishbones must have evolved from an animal with a collarbone. But while Compsognathus didn't have a collarbone, perhaps one of its relatives did. Dromaeosaurs, fast and mean. Among the fastest and the meanest of the meat eaters were the dromaeosaurs. These killing machines had a long head, sharp eyes, and a large brain for their size. Their front arms were also quite long for their body, and their 3 fingers had sharp curved claws. On their back feet, the dromaeosaurs had a slashing toe that they held away from the ground when they were walking or running. However, when they were attacking their prey, they used it to cut into their victims like a giant machete. Though dromaeosaurs were ferocious enough by themselves, it is possible they worked together in a pack to bring down larger animals. Iguanodontids, slow movers. Members of the iguanodontid family were heavily built plant-eating dinosaurs. They had long heads with toothless beaks for clipping plants and rows of teeth for grinding plants. They were heavily built, so in most cases they probably walked on all 4 feet, though they could rear up to reach food or defend themselves. They probably moved slowly, since the bones of their upper legs are longer than the bones of their lower legs, just the opposite of fast-moving animals. On their front feet, they had big spikes that would have been good for fighting off rivals or hungry meat eaters. Apatosaurus, the long-necked dinosaur. As you can see in this movie, Apatosaurus had a very long neck. It took advantage of its neck to reach the leaves and branches on the tops of trees, using its massive tail for support while standing on its rear legs. It had to eat tons of plants and leaves every day just to maintain its incredible body weight. These were not slow, defenseless creatures either. In a battle with its enemy, Allosaurus, Apatosaurus could have reared up on its hind legs and then brought its entire body down on its predator. Apatosaurus's long tail was also not a bad whip. Recently, Dynamation International Society has discovered what may be the largest Apatosaurus skeleton ever found. It may have measured up to 95 feet long. Rhamphorhynchus, sea skimmer. With its long beak and outwardly pointing teeth, Rhamphorhynchus skimmed across the late Jurassic seas, snatching up fish for its nourishment. Small and agile, Rhamphorhynchus was a member of a group of flying reptiles known as pterosaurs. Like other pterosaurs, Rhamphorhynchus flew through the air on wings made of thin skin that was stretched along their bodies to the very tips of their extremely long 4th fingers, or wing fingers. Well-preserved fossils of Rhamphorhynchus have been found in the limestone quarries of southern Germany, which show the membranous skin of their wings and long kite-like tails which helped guide these creatures in flight. It had a wingspan of about 3 feet 3 inches, and thin fibers running from the front to the back of the wings strengthened them greatly, much like the wing structure of the modern bat. Rhamphorhynchus's tail was also very long and strengthened by many thin, bony rods that ended in a small, flared-out flap of skin resembling a kite. Making tracks in Texas. Dinosaur trackways are some of the most informative fossil remains to be found. Fossil tracks were formed when dinosaurs walked over wet sand or soil and left an imprint which was quickly covered with sediment and thereby preserved. Most often, this occurred along the sides of rivers or lakes, where dinosaurs might have traveled. One of the most famous dinosaur trackways was discovered in Texas, at a place named the Glen Rose Formation. These fossil imprints show 23 overlapping trackways made by a large number of four-legged plant eaters, most likely the giant Apatosaurus. There were trackways of both young and adult dinosaurs. At first, scientists thought the great number of tracks was proof that these dinosaurs traveled in large herds. But now scientists believe that the tracks were probably formed around the side of a lake, where many large dinosaurs may have traveled at different times. These tracks also helped disprove a common myth held about the way large four-legged dinosaurs, like Apatosaurus, known as sauropods, carried their tails. Most believed that sauropods dragged their immense tails along the ground. But the Glen Rose tracks had no signs of tail marks, which meant that even giant sauropods held their tails aloft. Cretaceous. The continent split. Both giant continents, Laurasia and Gondwana, began splitting during the Cretaceous period. Mountains began growing, and the seasons became more pronounced. Flowering plants spread, and by the end of the Cretaceous period, oak trees, hickories, and magnolias were common in North America. The forests began to look almost modern. During this time, toothless bird-like dinosaurs appeared, as did the greatest of the meat-eaters, Tyrannosaurus. But the meat-eaters were matched by heavily armored plant-eaters, such as Triceratops and Ankylosaurus. Duck-billed dinosaurs with mouths designed for eating tough plants were common. Large flying reptiles and water birds soared above the earth, and there were many animals that are with us today. Lizards, snakes, frogs, salamanders, and small mammals like possums could all be found. Then, 65 million years ago, it all came to an end. The dinosaurs died out completely and quickly, perhaps due to comets or a meteor striking the Earth, or perhaps due to climate changes. Pachycephalosaurs, the boneheads. Like modern mountain goats, it seems pachycephalosaurs, or thick-headed reptiles, like to bonk each other on the heads. All the dinosaurs of this group had incredibly thick dome-shaped skulls, some with bony knobs and spikes on the sides of their heads and along their snouts. Some scientists believe that male pachycephalosaurs butted heads for the right to rule the herd. These rare two-legged plant eaters had 5 fingers and 3 toes, and probably ate fruit, leaves, seeds, and perhaps insects. They lived mostly in North America, but also in Europe, Central Asia, and even Madagascar. Seismosaurus, biggest of the big. From preliminary investigations, Seismosaurus, or earth-shaker reptile, is the largest dinosaur ever found. Bigger even than Supersaurus or Ultrasaurus, both found in Colorado. Seismosaurus, located in central New Mexico but not yet fully excavated, may be as long as 140 feet. It is related to Diplodocus with long front legs, shorter back legs, a long neck, and tail. To get a feel for its possible size, think about this. A single vertebra scientists found measured 5 feet long. Velociraptor, the killer. As you can see in this movie, Velociraptor may not have been as large as its victims, but it could still bring them down. It had a large back toe that was good for slashing at the underside of large dinosaurs. Some scientists think this savage dinosaur hunted in packs. Brontosaurus. Swamp to treetop. Scientists used to think that Apatosaurus, once known as Brontosaurus, was exclusively a swamp dweller. They thought this huge animal, the size of 6 elephants, was far too heavy to support itself outside the water. The water, they said, would help keep the 33-ton giant from collapsing from its own weight. But then they uncovered clean, sharp, fossilized Brontosaurus tracks. The tracks were not in mud, the kind of surface you would expect at the bottom of a river, but in sand. Also, right next to them were the footprints of the deadly Allosaurus, which was undoubtedly a land-dwelling dinosaur. Unless the Allosaurus had been scuba diving, this meant Brontosaurus was perfectly able to get around on land. Now scientists believe Brontosaurus was a land animal that grazed on leaves and branches from the tops of trees. Apatosaurus. Thunder lizard. First there is the crashing sound of plants and trees being trampled, then the terrible shaking of the earth. In the distance, an immense shape the size of a small building appears. Apatosaurus used to be called Brontosaurus, which meant thunder lizard, and referred to the loud noise this enormous dinosaur must have made as its 33-ton body lumbered across the plains of North America. Scientists no longer use the name Brontosaurus because the first fossils to be discovered of this creature were actually given the name Apatosaurus. Apatosaurus was one of the largest animals ever to walk the earth. It belonged to the group of plant-eating sauropods that included Diplodocus and Camarasaurus. Like these other dinosaurs, Apatosaurus had a very long neck and an even longer tail. An adult Apatosaurus measured up to 70 feet in length and had a tiny head in comparison to its body, only 22 inches long. Although not as long as its close relative Diplodocus, Apatosaurus weighed nearly 3 times as much, primarily because its bones were denser, and its heavy tail was made up of almost 82 interlocking vertebrae. Archaeopteryx, the early bird. In 1861, when German stonecutters discovered the nearly perfect fossil imprint of Archaeopteryx in a block of 140 million-year-old limestone in a stone quarry, they didn't know what to make of it. At first, scientists thought the fossil was the imprint of a tiny, meat-eating dinosaur. Then they realized that the faint outlines surrounding the skeleton were actually imprints of feathers. As it turned out, the discovery of Archaeopteryx was one of the most important finds ever. It proved what many scientists had long believed. There was a strong link between the dinosaurs of long ago and the birds we know today. Indeed, Archaeopteryx was something of a cross between a dinosaur and a modern bird. About the same size as a pigeon, it had a small head, large eyes, and feathers which covered most of its body. But like dinosaurs, Archaeopteryx had teeth in its jaw, claws on its fingers, and a long bony tail. Also, the bones throughout its body were much heavier than a bird's, and it didn't have as many muscles with which to flap its wings. Instead of flying, Archaeopteryx probably used its wings to fly short distances, or glide from tree to tree, catching insects or occasionally attacking small animals on the ground. The turtle, a real survivor. If you were to go back 200 million years, one group of animals would look almost exactly the same as it does today, the turtle. Turtles are unique because they are the only reptiles that have most of their body enclosed in a shell. For the giant land turtles which lived at the time of the dinosaur, a sturdy shell was a must for use against meat-eating predators. The giant sea turtles alive at the time had fewer enemies, so they could survive with a lighter shell, which enabled them to move quickly through the ancient seas. Prehistoric turtles measured anywhere between 6 inches and 12 feet long. Perhaps the most interesting of these was Testudo atlas, at 8 feet long and 4.5 tons, the largest of the land turtles. Testudo, alive in the Pleistocene epoch long after the dinosaurs disappeared, was also called Colossocheilus, which means colossal shell. It had a sharp, toothless beak which it used to tear up plants. It supported its massive shell with 4 pillar-like legs that stuck out from either side of its body. If attacked, Testudo atlas could retreat fully into its huge shell, where it was totally protected from even the fiercest of predators. Ultrasaurus, the biggest dinosaur? In 1979, the famed fossil hunter James Jensen made an amazing yet frustrating discovery. While excavating a dinosaur site in western Colorado, he unearthed one of the largest dinosaur legs ever known to man. Unfortunately, all he found was the leg. Belonging to the same sauropod family as Brachiosaurus and Apatosaurus, this giant plant eater, now known as Ultrasaurus, could have measured up to 98 feet in length and weighed an enormous 130 tons, making it the largest land animal ever. Its front leg alone is about a third larger than that of Brachiosaurus. Someday we may find the rest of Ultrasaurus. Deinonychus, small but deadly. Deinonychus was not very large, but it certainly was deadly. Some think that Deinonychus was one of the most ferocious dinosaurs ever, and that is easy to believe after seeing this movie. Measuring only 7 to 10 feet long, these small, fast-moving predators could bring down dinosaurs many times their size. Scientists believe Deinonychus hunted in packs, which would surround and overpower large dinosaurs, such as slow-moving plant eaters. Deinonychus was well adapted for hunting. It had fast, powerful thighs and a large head with sharp teeth that were perfect for biting off pieces of flesh and holding small prey in its mouth. Deinonychus's unique trait, however, was a single, large, curved claw found on both of its feet. When Deinonychus was walking or running, the claw was pulled back so it wouldn't interfere with the dinosaur's movement. But when Deinonychus was attacking, the claw was lowered so it could be used as a sharp weapon. Deinonychus likely grabbed its prey with its mouth and hands and tore at its victim's underbelly. To maintain its very high level of activity, some scientists believe that Deinonychus had to have been a warm-blooded animal. They say that a cold-blooded animal would have been too sluggish for Deinonychus's active lifestyle. Iguanodon, not an iguana. In 1809, part of an iguanodon's giant shin bone was found in southern England. In 1819, some teeth and other bones were discovered, and scientists at the time thought they probably belonged to a gigantic mammal, like a rhinoceros. But then the geologist Gideon Mantell noticed that the teeth resembled those of a modern iguana, so he named the creature Iguanodon. Iguanodon was the second dinosaur to be discovered, even though the word dinosaur had yet to be coined. Iguanodon stood about 16 feet tall, measured 30 feet long, and weighed close to 5 tons. It roamed the warm, humid Cretaceous landscape and fed on the rich abundance of plant life covering the land. Large numbers of iguanodon skeletons have been found in England, Belgium, and Germany, indicating to paleontologists that Iguanodon probably traveled in large herds. Iguanodon had small hooves on its hands and feet, and its legs were long and sturdy. This giant dinosaur could have stood on its back legs to reach for higher bushes and plant life. Baryonyx, fishing dinosaur. Baryonyx is a recently discovered dinosaur that appears to have been especially well suited for fishing. If so, it is the only known fishing dinosaur. Baryonyx's nostrils were set back from the tip of its long, narrow, crocodile-like snout, perhaps so it could stick its nose underwater and still breathe. It had a mouth full of small, sharp teeth, twice as many teeth as most dinosaurs, which were probably great for catching fish. Baryonyx, meaning heavy claw, takes its name from the 2 huge curved claws, more than a foot long, that seem to have been attached to its front feet, where they would be handy for spearing fish. However, since the claws were not attached to the skeleton, scientists are not certain whether they were on the front or back feet. Another piece of evidence for Baryonyx's fishy diet is that scientists have found the remains of a fish dinner where its stomach would have been. Because of its long front legs, scientists believe Baryonyx may have walked part of the time on all 4 legs. Baryonyx was discovered in 1983 by an amateur fossil hunter in Sussex, England, and is related to the Spinosaurus. Hadrosaurids, the most common dinosaur. Hadrosaurids were among the most common dinosaurs. They've been found all across the northern hemisphere and even in a few locations in South America. Hadrosaurids were plant-eating dinosaurs. They all had long faces and flattened snouts that looked like duck's bills, so they are often called duck-billed dinosaurs. The fronts of their mouths had no teeth, but they had plenty of teeth inside their mouths. The hadrosaurids used these teeth to grind up tough plants and vegetation. As their teeth wore down, they would be replaced with new ones. Hadrosaurids probably walked on all four legs when they were eating, then rose up on their long back legs to escape from meat eaters. Lambeosaurids, hollow heads. Lambeosaurids were duck-billed dinosaurs with a curious feature other duck-bills did not have. On their heads were all different shapes of hollow crests and bumps and horns. The Lambeosaurs could breathe through these long nasal passages, and perhaps could signal to one another by blowing through them like a trumpet. Some scientists have suggested that they were also good for attracting a mate. Lambeosaurids probably traveled in herds, living in swampy wetlands that covered much of what is now North America. Maiasaura, good mother dinosaur. The discovery of a large number of Maiasaura fossils has given scientists new insight into the social behavior of dinosaurs. It turns out the duck-billed Maiasaura like to hang out together and take care of their young. There are two major clues scientists have used to come to these conclusions. One is a vast boneyard that scientists have discovered in western Montana. The area is filled with as many as 10,000 skeletons of one particular kind of hadrosaur, the Maiasaura. Also, these skeletons range from about 10 feet long to 23 feet long, suggesting this herd was made up of different age Maiasaura. Apparently they had died from the smoke and fumes and ash of an exploding volcano. This is significant because it shows Maiasaura was not a loner, but lived together in herds. Another significant find in Montana was a nest of 15 baby Maiasaura. The babies were about 3 feet long, 3 times the size they were when they were born. Scientists know newborn Maiasaura are about a foot long from other nests. Why weren't these big, strapping young dinosaurs out on their own? Most reptiles are ready to face the world the moment they are born. This is the question scientists had, and there are 2 possible answers, both which suggest these dinosaurs had a strong family relationship. Either the parents brought food to the young dinosaurs, or the young dinosaurs went out for food and then returned to the nest. Both these possibilities suggest a strong family relationship between parents and children. No wonder the word Maiasaura means good mother lizard. Orodromius, fast runner. Orodromius, meaning mountain runner, was a swift-footed dinosaur about 6.5 feet long. It had long running-type legs, short arms, and simple teeth that it may have used to eat fruits and perhaps insects. Mother Orodromius laid about a dozen eggs at a time in a spiral. When the little dinosaurs were ready to hatch, they pecked their way out of the shell. Euoplocephalus, all secure. With all of its heavy armor and thick bones, Euoplocephalus seems like it would be slow and clumsy. Quite the contrary. Because its armor plating developed in narrow bands, Euoplocephalus was quite agile for a dinosaur of its size and mass. Living up to the end of the Cretaceous period, Euoplocephalus was one of the largest of the armored dinosaurs known as ankylosaurs. It weighed close to 2 tons and measured 18 feet in length. Bands of armor were embedded in its back and covered with large bony knobs. There were also pointed spikes at the back of its head, over its shoulders, and at the base of its tail. Like its close relative Ankylosaurus, even its eyelids were armored with bony plates that slid down to protect the eye socket when the dinosaur was in combat. In combat, Euoplocephalus must have been quite a fighter. Even its natural enemy, the powerful Tyrannosaurus, would have had a tough time breaking through Euoplocephalus's heavy body armor. Meanwhile, Euoplocephalus would try to scramble around until it could swing the massive bony club at the end of its tail toward Tyrannosaurus's legs and stomach. A direct hit might have been fatal. Elasmosaurus, longest marine reptile. Measuring 46 feet in length, Elasmosaurus was the longest known plesiosaur, or marine reptile, to roam the seas of the Cretaceous era. Elasmosaurus's neck alone measured close to 26 feet, more than half its body length. This snake-like neck was made up of more than 71 vertebrae and was 3 times longer than that of any of its near relatives. The rest of Elasmosaurus's body was sturdy and compact. Its tail was short, and its huge paddle-like flippers were perfect for propelling Elasmosaurus through the water, much like a sea turtle does. Scientists think that Elasmosaurus spent much of its time swimming with its head just above water, scanning the waves for small fish and squid to eat. Like Plesiosaurus, Elasmosaurus probably only left the water to lay its eggs in the sand. Corythosaurus, Corinthian helmet reptile. Corythosaurus is certainly called the Corinthian helmet reptile for a good reason. With its unique head crest, Corythosaurus is one of the best known of the duck-billed dinosaurs, called hadrosaurs, which inhabited the dense forests of what is now Montana and Canada at the end of the dinosaur age. Measuring 33 feet in length and weighing 5 tons, it was also one of the largest dinosaurs of its kind. Of course, the most amazing feature of this massive plant eater was the large, almost 1-foot-high hollow crest on the top of its head. Shaped like a large upright dinner plate, this crest spanned from the front of the dinosaur's forehead to the back of its skull. Like other crested duck-billed dinosaurs, Corythosaurus's crest was filled with nasal passages. It is still not entirely clear what these crests were used for, and why some hadrosaurs had them, while others did not. The most popular theory held today is that the crest functioned as either a sounding device that enabled Corythosaurus to warn others of danger, or as an enlarged sensory area, which increased the creature's sense of smell. Another possibility is that the crest was used for cooling the animal under the hot sun. Other scientists believe the crest may have been brightly colored to attract a mate, or so one Corythosaurus could recognize another.